Now I'm just going to talk very, very briefly about another Merkle tree application, torrenting. Suppose I want to upload a large media file, like say a game. The games are quite large. It would take a long time to download a game or upload a game from someplace, right? So what you do instead is you might much more quickly upload different bits of it at the same time from different sources. And that's how things like BitTorrent work. And the Merkle tree is used in those systems as a way of keeping track of how those bits fit together. Okay? So that's just another application, an earlier application than Bitcoin. Okay, next stop, blockchains. Blockchains as a data type, getting ready for you to do some implementation. And so I'll see you at the blockchains. Bye for now. Welcome. We're now going to talk about the blockchain as a data structure. This is getting ready for your implementation. Okay, right. So the blockchain is going to use the Merkle trees. You won't be surprised to find. We'll see how that works in a minute. So this is a particularly short lecture as it happens, even though it's got the name of the whole module in it. But it's just very, very short, and it's kind of setting you up to do some programming. Okay, so what is the blockchain? We've said a lot of this before. The blockchain is a distributed ledger. I mean, what the phrase people use is an immutable distributed ledger, and we'll talk about the immutability later in this lecture. Okay, so what does that mean? It's a long list or ledger of transactions. That's one way of looking at it. It's just an enormous list of transactions. But the list is broken into sections called blocks. Okay? And everybody in the network has access to this whole ledger, to all these blocks. Okay? So that's the distributed part. The distributed part is everybody in the network gets access to it. The ledger part has got all the transactions in it. And the immutability we'll see about in a bit. The blockchain part, the block is just the section of transactions. Okay, so that's all the words we're thinking about. In practice, it's not quite like that. What happens is the blockchain actually grows one block at a time. And the way that works is people, really nodes, compete to build the next block on the chain. So they solve a puzzle, and that's the part of what we're going to do in the next topic. Talk about what that means, how you mine, and that's called mining. You mine a block by solving a puzzle, which is what's called proof of work. That's all a part of the next lecture, the next topic. So people compete, or nodes compete, to be the ones to build the next block. And the reason they do it is that they get paid to do it, right? The winner gets paid. They get the fees. Remember, the transactions frequently left the fee behind. Those fees go to the miner, to the node that makes the block. And until now, you also get paid for making the block. You get a fee for making the block, which will disappear at some point. Okay, and then the other thing about this, and we'll talk about this much in this lecture, is each block refers to the one before. That's the other bit about it. So what's in a block? Okay, so the block is mostly transactions. So we've got the transactions in a block, say around 1,000. They're pretty variable. Okay, so they're actually arranged as a Merkle tree, right? Misspelled Merkle here. Okay, and a header. Right, okay, so that's to be LE, Merkle, but, okay, so transactions arranged in a Merkle tree and a header. Okay, so what's in the header? That's what the rest of this lecture is about almost. Well, one thing that's really important in the header is the hash of the previous block, okay? So that's what it means. So it's a little bit like pointers, it's a little bit like linked lists. Each block has sort of, it's like having a pointer to the next block. It has the hash of the previous block. It's got the information, all the information about the previous, it says what the previous block is, essentially, and all the information. So that's really important, or at least a digest of the information, because it's got a hash of it, okay? That's where the immutability comes from, because what happens if somebody changes a transaction in a block? Well, then it messes up the hash of that block, which means that in the next block, when it refers to the previous block, that'll be messed up too, and the one after that, and the one after that, and so on. It just percolates all along. So it's a big mess. So soon if you can't go back and change a transaction without doing a lot of work. If you change one thing, you have to change a lot of things, and that's very expensive. Okay. Okay. The Merkle root hash. Okay. That's how Merkle spelled right. There we go. Which is called the hash Merkle root. Clever, these naming conventions. Okay, so what is that? That's the single string that's at the top of the Merkle tree in the block we're making, right? So there's two hashes here. There's a hash of the previous block, and there's a hash of my transactions arranged as the top of a Merkle tree. That hash is the hash at the top of the Merkle tree. Okay, so the picture of the data structure is kind of like this. These are stylized Christmas trees, blue for Christmas, and each of them is a tree. It's supposed to be a Merkle tree with the transactions in a block, and so each one of them represents a block, and they each kind of point through the use of that hash. They kind of point to the previous block. Okay. So the transactions are sort of arranged in this tree, this chain of trees. There's a way of looking at it. Okay, there's a sort of chain of trees. That is the way the transactions are all, the whole ledger of transactions is arranged. Okay. Another part of the header is a timestamp that comes from the Unix system, and it's this timestamp that gives a sense of when the block was created. In fact, I think it's the very moment when the hashing begins for the Merkle tree. Okay, another part that's important in the information of a block is called the nonce, and nonce stands for number used once, I think. Anyway, it is a number used once, and the point of it is that we're going to move this again. We'll learn more in the next topic, because this is about solving the puzzle. Solving the puzzle to do the mining means finding a nonce with a particular property, and we'll learn about that. So that nonce is a really important part of the block. When you want to make a block, what you do is you find a nonce with the right properties, and everybody on the network, or everybody who cares to look on the network, all the nodes in the network will say, yep, that works. Okay, and that nonce solves the problem for you, the puzzle, and we'll do that next time. And that's really all I want to say at this point, I think. Told you it was a short lecture. And okay, that's it for now.
Okay. Now we know what's Merkle tree. Now we know what information are inside each block. And the next step is talking about the mining process and the solving the puzzle. Okay? See you next in next lecture.